Figured out, you know what you're going to do?
Yeah.
I'm here to talk about engineering, specifically chemical engineering. That's what I do. And I originally grew up in Pennsylvania. I came to Texas about 15 years ago because it's one of the best states in the union for engineers and for other reasons. I mean, who knows why Texas is one of the best states in the country? Is it because of our state animal, small animal, the armadillo? What's our state bird? Does that make us the best in the country?
No.
How about the insect?
No.
Our fruit?
No.
Wait, I know what it is. Only we have the Alamo. That's got to be it.
No.
San Jacinto Monument, our independence.
No.
They're all good. What really makes Texas great are you all. Because you're the future of Texas, and you're the future of what's probably, in my mind, the best state in the country and possibly the world for technology and science. Because a lot of what we do here, from the space program to oil and gas, drives the economies worldwide. Now let's talk about that. Why are we good in what we do? Because we read, we understand a lot about the world around us. Science. Even water cycle, understanding the water cycle in the natural world. Math. Very important. These three things are important no matter what you do, but they're especially important in engineering. And when you work on those, you need to get good grades, and we do get good grades. Montgomery schools are very good. Why? Because we have the best teachers. So, when we take science and math, and we apply that in ways to create new ideas and products and solutions, we call that technology. And science can be a lot of fun. I know some of you guys are saying, you know what, I don't really like math. I do it because I have to. Grumpy Cat's right with you on that point. Grumpy Cat says no to science and math. But I've been doing this for a long time. And I'm telling you. And by the way, Grumpy Cat was Sam's idea. I originally had a surprise monkey, but he said no, Grumpy Cat would work better. So I have to give credit for that.
That's the face he makes every day.
Now, when we take math and science and we develop new things, which I already said is called technology, to improve our way of life, let's look at some examples of how we do that really we all identify with. The iPad. I mean, is that like the best technology today?
No.
Everybody wants an iPad. iPhone. But it's a pretty cool thing. I mean, it's a really, we're connected to the world, we can play games. Even stuff we take for granted every day, like food. Technology, there's a lot of technology that goes into growing food. The fertilizers, the way it's farmed, the technology that goes into the various seeds and fertilizers. There's chemical engineering in that. The space program. We're in the hub of the space program. Even though the space shuttle has been retired, we're far from through with the space program. All the developments that we experience today, we take for granted, are largely responsible by virtue of the space program. And even things... Even the things we take for granted every day. There's a lot of technology that goes into making them, whether it's detergents, cleaning materials, dog and cat food, coffee. It's not, it just doesn't happen on its own. Engineers are the ones who take, starting out with math and science, even the problems you're doing at home, the teachers give you the math problems or the science problems. That's where it all starts. You apply that, create a new idea, come up with a new product, new material, something that's useful. That's what an engineer does. Now, I happen to be a chemical engineer, so I tend to work with chemicals or chemistry. However, there are all kinds of engineers. You don't necessarily need to be a chemical engineer to apply math and science. There's mechanical, who works with engines and gearboxes and drives and components, structure of things. There's electrical that develops the circuitry that goes into computers and anything that uses electricity. Regardless of what type of engineer you are, you tend to enjoy or focus on. A few key elements are at the crux of it all. One is the scientific method. I was just sending emails before I started today with a guy I've been doing this for 35 years, 20 years my senior. I said, hey Bob, we need to come up with a plan, which is another way of saying scientific methods. What are we going to do? What do we need in the lab, the materials? What procedure are we going to follow? What do we think is going to happen? And you always know something's going to happen. You always think you know what's going to happen. You seldom do. That's what makes science fun, by the way. It's always fun that the results never quite what you expect. So you learn something new. But when you reach a conclusion that maybe isn't what you expected, then you may want to go back and redo some new experiments. That's a scientific method. I tend to work in the environmental industry. My company, Veolia, is quite large. You guys probably haven't heard of them, but we're 336,000 people worldwide. My division is 70,000, to put in perspective, about the size of Toyota. And we focus on petroleum, upstream and downstream production, refining, mining, metals finishing, steel industry, chemical industry, anything that has to do with industry's impact on natural resources, not just water. Water tends to be the vehicle that carries things. So a lot of things will dissolve in water. They can be contaminants or they can be products that you want, like when you put sugar in there for your iced tea, that's a good thing. When you put acid in there, you can't really throw that to Lake Conroe. Chemical engineers will come in and say, how can we pull that out and make the water clean? All the elements of the periodic table. If you guys haven't seen the periodic table yet, it's a structured way of keeping track of all the various elements that the world's made up of. I work with quite a few of them and doing a lot of laboratory work. What I'm going to show you next is just some examples of what I've done and where I've gone. This here is a reactor that I use to, what I'm filming here, second stage reactor slowed down on the mixer, demonstrating how discrete the crystals are in the second stage. Much improvement after recognizing that our carbonate feed was very lean. We're now getting
7-hour run.
1.15 GPM per square foot coming out of the second stage. That to me looks like it'll be water. Right in Nevada and California. Rare earth elements are very critical elements used to make various electronics, computers. They're used to make very strong magnets that go into hybrid cars, electric motors. They're used to treat glass and metal materials to give a very high temperature resistance, like the space shuttle windshields were coated with a rare earth that gave them the resilience to entering the atmosphere at a high temperature. They go into dentistry products to give teeth, false teeth and caps and crowns with sort of iridescent type natural look, and various other proprietary applications that I won't even get on, but they're endless. And China generally has a big market for the rare earths. They make most of them, but the United States is trying to capture about 40% of it. And my companies are helping them do that. And if we can do that, that material, just to give you an idea how much it's worth, if you had a bag about the size of this computer, it'd be worth about $100,000. Some of them are so novel and valuable that it'd be worth $500,000. And I'm out there working with it in super stack bags sitting next to me that are worth millions of dollars. And it's very important to the economy of the United States. And this is where you guys can contribute with your science and math skills to help us become #1 in the world. Another metal that's probably a lot more familiar to you all is aluminum. Planes are made out of aluminum. bicycles, BMX bikes, made out of aluminum. There's a lot, anything that you want to have strong and light is made out of aluminum. Brazil is a big producer of aluminum. They have massive basins full of water that they've used to extract aluminum from the ground, and they need help with recovering the trace amounts that are still in there, so that they don't have any discharge.
Aluminum hydroxide or something like that?
There was about, what was it, 1,300 parts of aluminum in there we measured?
Yeah, that sounds right.
Process to clean the water.
It's a lot of, it's kind of got the
It really is.
classical carbonate type, crusty.
Hard, crusty, the edges break up easy, but that bottom, oh, look at the bottom's flaking off. Oh, cool.
It's like a 1/16 of an inch thick.
Flakes.
We should take some and put it in acid, see if it fizzes. Quick and dirty. Qualitative and analytical.
Treating water recovery materials generally provides very good incentive to do it, because it's no longer just a cost, you're actually producing something
Cool.
of value. Wastewater, I won't get into that because I've run out of time. So when you're dealing with large volumes of water, as we've learned here in the last couple of years, when droughts hit, Lake Conroe goes 5 feet low. That's a really sad thing to have happen. So it's important that you manage water very optimally, because companies like oil and gas or big industries like mining that use a lot of water can't drain our rivers and lakes, and we won't have any water to drink. This project here is a project I worked on 2 years ago that we just started up, the trees. 60,000 barrels a day of water that comes out of the ground. Now, this is an important project because remember when I talked about the oil and gas and how the United States is going to become energy independent? When we drill for oil and gas, not just the oil and gas comes up, water comes up too. So we need a good, efficient way of treating that water, so when we put it back into rivers and lakes, it doesn't contaminate the fish or cause any harm to the public. And that's what this project does. And we need more engineers getting involved, because right now we are just at the beginning of what could possibly be an enormous change in the momentum in the market for oil and gas, and whereas the United States will become, and already has become, a producer of refined products rather than just a strict importer trying to sustain itself. So there's a lot of money to be made, which means you can buy a lot of cool stuff, and it's a lot of fun. You get to go different places. Here's a laboratory experiment that I worked in Florida. And you meet a lot of interesting people. I just pulled one on. He happened to be the technical manager of a company called Mosaic, which is now owned by Cargill, who makes all the honeysuckle turkeys and chickens and makes all the fertilizers and nutrients for livestock, an enormous company. And he is one of the brightest minds out there as far as developing new technologies to clean water up so that it can be reused while we're recapturing products that are in there rather than just disposing them to the environment at a cost. Because nobody wants to spend money to get rid of something. If you can make money instead of throwing something away, that's what drives engineering. Here's another good example. When you make steel, it goes into cars or washing machines. help companies like US Steel and AK be much more cost competitive versus other steel fabrication in the world. We come up with, even as chemical engineering, come up with ways to mix things better, to get better reactions. Reaction is taking two materials, when they come together, they make a third product. That's fundamental chemical engineering. What we get to do as a chemical engineer, or really any engineer, is you get to see cool places. I've been everywhere, not just Florida and Brazil, England, very beautiful country. The whole country's a garden, they say. Paris, France, that's where my company's based. So I get to go there quite often and pretend like I'm working, but I'm really going on vacation and eating good, and there's a lot of fun things to do there. Another state that's rising in its power and contribution to oil and gas are the Dakotas. Also, corn ethanol. This is a project I was working on where they actually take corn and make ethanol out of it. It goes into anything from mixtures into gasoline to displace other toxic materials that were used, to liquors that are used in the liquor store right down the road. So, Brazil. Who knows what that little critter is on the right-hand side? What is it? Who's from Brazil here? Anybody?
Dylan?
You know what it is?
I know what it is.
Dawn?
It's not the name.
What is it?
Yes.
Maybe a capybara.
Yes, it's a capybara. That's the biggest rodent in the world. They run around like Labradors at the refinery, Petrobras, and snorting and jumping in ponds, and they come over and they want you to give a piece of your lunch. And Brazil is probably one of the strongest rising economies in the world from the resources. And we spent a lot of time down there, not just dancing and partying, but actually working and trying to take the ideas of the United States to help them develop. Chile. You know where Chile's at, right? In South America? One little strip along the left side. They're the biggest market for copper in the world. This pond here that I was working on is from here over, it looks short, it's about 5 miles away. It's an enormous pond. It's on the order of Lake Conroe in terms of volume, and it's full of salty water that needs to be cleaned up. We developed a process to clean the water up so that it could be discharged for agricultural uses, meaning we could grow stuff with it that you could eat. Where did the limits for the agricultural quality come from? The United States. They just copy us because they said, you guys have already done it, you're leading it, come down here and show us how to do it. So I don't want to come across like we have it all figured out, but as I said at the beginning, we're the best. And you guys are going to be the future best, and that's why I'm trying to show you some of the things that I'm working on that you can continue on with. One important point with engineering, while you generally work in teams, that doesn't mean you won't come up with a good idea someday on your own. I did that myself. One day I come up with an idea that I was going to recover some materials from the refining industry. I never even been in the refining industry because I took some ideas I learned from something else and I applied it and it worked. And over 5 years, 7 years time, the refining industry applied at 80% of the refineries here to make gasoline. So my process that I came up with is in about 80% of the refineries here in the U.S. and we're moving it to the U.K. and then the other market where gasoline's used favored over diesel. There's a lot of money to be saved here. I got the governor's award of the state of Pennsylvania from then Governor Ridge, who became Homeland Security. You guys are probably too young for that, but it's pretty impressive stuff. My point is to say there's really no limit to the impact you can have with your ideas. And there's a lot of big companies out there with a lot of good thinking and funding, but it could be you, it could be you, it could be you that comes up with an idea that nobody thought of. It really changes the world. But to do it, you're going to need to know the basics, the science and math that you're working on right now. I've been to Mojave Desert. Let's look at the advantages of an engineer, in particular a chemical engineer. And I've already mentioned a lot of them. You get a wide range of jobs. You could be a chemical engineer and work with Applied Materials, who's a company that makes the machines, that makes the chips that run in here. You could be, you could work over at April Sod developing the new water treatment plant that's expanding. There's no end. You get to travel and see the world. Companies like that. If you're willing to travel and see the world, that's kind of like when you're starting out. Well, that's a cool thing. Well, no, a lot of companies really love to see that because you become very valuable to them if you're willing to do that. You're always inventing and discovering new things. You can make a lot of money. Now, the chemical and petroleum engineers are generally the highest paid engineers in the full spectrum of mechanical, civil, architectural, aeronautic, maybe competitive. But here in Texas, where we're at the hub of oil and gas in the petrochemical industry, taking the products from refineries and making things out of them, like this chair, like the plastics that go into anything, this bottle I'm holding, there's no end to it. So you're in a good place, and you're in a good place at a good time, and the future is very bright for you. Even if you don't want to do chemical engineering, it's a solid basis to move into things like medical. If you guys want to become a doctor, a lot of doctors start out getting their engineering degree, and a lot of them start in chemical, because the math and science and the basics that you get there are they lend themselves very well to fields of like medical, law, and even government. Understanding chemistry is important towards managing industry and society. The most important thing, though, for me is just fun. If you're not having fun with what you're doing, it doesn't matter how much you're making or what the problems are. You're not going to like it. You have to find your passion. And when you find your passion, the thing that you really like to do, you never work again. Because basically the paycheck becomes something that you get as a side benefit. Yeah, as a bonus. And you get to meet a lot of different people, a lot of diverse backgrounds and cultures. And there's an endless number of people that I've run into from different walks of life and countries. But it's not all roses. There's a couple things you need to keep in mind, and this is why I'm pushing math and science really hard. It's hard. I mean, science is not always easy, and it takes time to learn it, and you have to put forth an effort. If you like it and you're willing to put forth the effort, you will succeed. Even if you say right now, hey, I really kind of struggle with math, I don't really like it, maybe it's not for me, but I like it, stick with it. Because some of the best folks that I've run into that have made the most advances, like when Hurricane Katrina hit Texas, I had folks operating plants that I built do things that I didn't even think of to keep them running, to keep the Gulf Coast infrastructure intact. And they have no college degree. They just came out of high school. What they have is passion and a willingness to learn, and that's all it takes. Don't get me wrong, the schooling's good, and the more the better, because it really helps you broaden your ideas. But passion and the ability to work hard is a big part of it. It's demanding, you have to travel a lot, it gets tiring, it's not always easy. And then even when you get out of school, you have to put forth a lot of effort just to learn the things you need to learn to be productive. So it's not always easy, but I'll ask you a few questions, and you can just answer them in your own mind. If you're interested in the world around you, how things work and why things do what they do, engineering, maybe not just chemical engineering, is right for you. If you like to take things apart and you're curious about the way things work, maybe you take things apart and your mom says, you ruined that. Well, you learned something, but engineering is, it may be a good avenue for you. If you get good grades and you really like science, math is important, and you really like science and you're working hard, and you like it, then it's a good avenue. Since engineers tend to be people that learn things that the rest of the world do not understand well, you have to be a good writer, and you have to be able to tell people what you've learned, because if you're the only one that understands it, and you can't communicate that very well by writing it down for folks that need to use it, then that's not good. So you have to be a good writer. Writing for me is probably right up there with science in terms of importance. So, and if you're a good writer, you can do anything. Everybody's looking for good writers. You like to compete, you're competitive, and that's a good thing. You notice the details, you observe things in the world. You don't just look at something and say, oh yeah, take it for granted and move on. You really want to know why does it do that, you know? And you like to work in teams, because teams of people are important to get a lot of perspective and diversity in ideas. We need more engineers in the United States. We need more students that are willing to work hard. We need more girls in engineering. I manage 8 people in my process engineering group. 2 of them are women. They're excellent engineers. So girls, don't let the guys or the boys that say, well, she doesn't like to understand what the kinetics say. She doesn't take apart the things. That's not important. That's the things that people think are important for engineering. What's really important for engineering is that you're good at math and science. Because I can tell you, if you come out, there's a lot of companies out there doing a lot of interesting things that can use your skills, just the same as the boys. So women in engineering are very well sought out. And even if you don't like anything I told you today, if you like the idea of engineering and developing new things, I would encourage you to look at mechanical or electrical. Because if you're more mechanically inclined and you like to maybe ride your dirt bike and figure out how it works, then the mechanical engineering is. But even if you don't care about any of that stuff, and you say, you know what, after listening to Mr. Cook, I don't want to be an engineer at all because that sounds really boring. I can tell you that you need to still study hard in your math and science because those are basic skills that you're going to need no matter where you go. Even if you're an accountant or you move into a field where you're not really doing experiments or learning new things, what it's teaching you is not necessarily the science and math. It's teaching you how to think. It's teaching you how to solve problems. And nothing can do that better than the math. Any questions?